let's discuss about types of motion. So there are only two possibilities of motion. So the first type is called uniform motion and the second type is called non-uniform motion. So what is uniform motion? So we define uniform motion as if equal distances are covered in equal intervals of time by a body, then we say that the body executes uniform motion. And similarly, for non-uniform motion, different distances are to be covered by a body in equal intervals of time. So let me give you an example. Let's assume that we have got a car. So car is in a traffic jam. So car stops, starts. So the motion of the car is discontinuous. So this is an example of non-uniform motion. For a uniform motion, it has to go in a flow. And it has to go in a flow in such a way that at equal distance, it covers always equal distance. If it covers 5 kilometers in 2 seconds, for next 5 kilometers should also be covered in 2 seconds. So this is what we mean by uniform motion. So in this chapter, we will be giving a lot more importance to uniform motion. So first, let's study about change of motion. So we know that something moves in time. So one quantity that we have for studying about change in time is the rate of change of motion, rate of motion. So the first quantity that we will be studying is called speed. The speed is defined as the ratio of distance covered divided by time taken. So what is the unit of speed? So the SI unit of speed is SI unit of distance divided by SI unit of time. So what is the SI unit of distance? The SI unit of distance is meter and the SI unit of time is second. So the SI unit of speed is meter per second. Other than that, the speed can be also mentioned in other units like kilometer per hour, centimeter per second. So whatever be the units, so we will have in our problems, we will have to convert the non-SI units. This will be called as a non-SI units. The non-SI unit should always be converted to SI units, meaning kilometer per hour has to be converted to meter per second if the answer has to be reported in SI units. Now, we define one more quantity that is called average speed. So, when do we need average speed? We need average speed when the speed of a body keeps on continuously changing. If there is a unique speed, we know that it is uniform motion. But if the speed keeps on changing, like non-uniform motion, so we will need to specify a quantity which is called average of the speed. So, the average of the speed is defined as total distance covered divided by total time taken. So, there can be multiple speeds, but we take the total distance that is covered between the initial and final position and then divided by the total time of the journey. Let's do a small problem. So here we are having the total journey is from A to D. So it has gone through A, B, B, C and C, D. Now, so the AB is 12 kilometers. This 12 kilometers is covered in 1 hour. BC 10 kilometers is covered in 2 hours. And finally, CD is covered 20 kilometers in 4 hours. Now let's ask the question. So what is the speed from A to B? So the distance is 12 km divided by 1 hour. So we'll get 12 as the answer. 12 km per hour. The speed for BC, so it has covered 10 kilometers, the distance divided by 2 hours. So we will be getting 5 km per hour. And for CD, we will have 20 divided by 4, 5 km per hour. So always remember it has to be reported in units, proper units. It is not meter per second or centimeter per second, it is just kilometer per hour. Now we ask the question, what is the average speed for the entire process? The average speed for the entire process is the total distance covered, that is this entire long path AB plus BC plus CD divided by the total time. So if you do, so the total time is 1 plus 2 plus 4, 1 plus 2 plus 4 hours. So this is the total distance and finally we get 6 km per hour. So there are multiple speeds, but the average speed is the averaged value of all the speeds. Now, let's introduce another quantity called velocity. So the speed, we know that speed is just the numbers. Like the last problem we have seen 6 km per hour. If I add direction to this speed, we get a new quantity which is called velocity. So velocity is the speed of a body moving in a particular direction. This is a simple definition of velocity. Velocity is the speed of a body moving in a particular direction. So how to change the velocity? To change velocity, you either change the speed or you change the direction. So these are the two possibilities in which you can change velocity. And the velocity is defined as the ratio of displacement and time taken. We know that the unit of displacement is equal to the unit of distance, and that is meter. Time taken, the unit is seconds. So the velocity SI unit will also be meter per second. Now let's consider a problem. Just as before, we have got a long path and a short path. So long path A, B, C, D, initial position A, final position D, 12 meters, 18 meters, 12 meters. So time taken for covering AB, TAB is 2 seconds. The time taken for covering BC, TBC is 6 seconds, CD is 3 seconds. Now let's ask the question, what is the velocity of this body? The velocity, remember, the velocity depends on the displacement, not the distance, the displacement. And we know that the displacement is the shortest path connecting the initial and final position. So the initial position is A and the final position is D. So in spite of it taking a long path, we have to worry about just the shortest path, that is AD. AD is 18 meters. So what do we do here? The displacement is 18 meters. And we know the time. The total time is 2 seconds, 6 seconds and 3 seconds. And finally, we will have the velocity is 18, the displacement, divided by the total time. So 18 by 11 meter per second. And average velocity. So the average velocity is, so we will give you a formula. So this formula is specifically applicable for situations where the motion is uniform. So that is initial velocity plus final velocity divided by 2. Remember, this formula is applicable only for uniform motion. For non-uniform motion, we will have some other formula. We will be focusing mostly on uniform motion. So usually the initial velocity is denoted by u and final velocity is denoted by the letter v. So u plus v by 2, that is for the average velocity. And the more general formula for average velocity is total displacement divided by total time taken for the entire process. Now let's do a small problem. So here we have Usha swims in a 90-meter long pool. She covers 180 meters in 1 minute. Find the average speed and average velocity of Usha. So in this question, the units are given in 90 meters and 180 meters. Those are SI units. But the time is given in 1 minute. So we have to convert. In this problem, we have to convert it into SI units. That is seconds. We know 1 minute is 60 seconds. So in 60 seconds, Usha is covering 180 meters. We have been supposed to find what is the average speed and average velocity of Usha. So let's draw the figure for the problem. So this is a 90-meter long pool. So Usha has begin swimming from point A, and after one lap she has reached B. So the initial and final positions are the same. So this is one point you have to keep in mind. So first let's ask, what is average speed? The average speed is the total distance divided by total time taken. Total distance divided by total time. So the total distance for the entire lap is 90 plus 90. So 180 meters divided by 1 minute becomes 60 seconds. 60 seconds. We will have to do everything in SI units. So 180 by 60, that gives us 3 meter per second. And now, same question. Average velocity. So we know that average velocity depends on the total displacement. Since the initial and final positions are the same, there is no short path. So the shortest path is 0. So in such a situation, we can write the total displacement becomes 0. So straight away we get 0 meter per second.